Hello, my name is Judy, and this is assignment 2.3, Dimensional Modeling. Before, before we begin, first things first, we need to understand the business, the vision, and what is trying to be accomplished. We need to identify the key performance indicators, the business issues, the decision-making processes, and supporting analytic needs of the company. From there, we can have the framework to continue on, and we need to keep this in mind through the entire process. We need to stay aligned with what the business wants. As we start out, there's a 4-step dimensional process. First is to select the business processes, identify all of the operational activities that need to be captured in building the facts tables. Next, declaring the grain. Everything must align with the grain, kind of like the company's vision. In that, we specify what the records contain, identify the levels of detail, identifying the data as we keep this in mind, again, through the entire business process. After that, we can identify the dimensions, provide the who, what, where, when, why, and how context surrounding a business process event. Lastly, identifying the facts. You can see in the figure below how in the dimensional model we have the 4-step process in the middle, and on the left you have the business requirements, and on the right are the data realities. The fact table. Okay, what is a fact table? Well, a fact table contains numerical measures measured by an operational measurement event in the real world. It is a basic unit and cannot be manipulated. A fact is a fact. For example, if an individual checked in for a flight at the airport kiosk at 9:55 a.m. with one checked bag, how many facts can be derived from that one event? Well, you can pull information like the customer information, loyalty number, flight information, check-in time, bags checked, kiosk number, ticket and bag voucher information, etc., just from that one particular event. How do we want to organize it though? Okay, there are 3 main types of facts. You have additive, semi-additive, and non-additive. Okay, additive facts are measures that should be included to all dimensions. Then you have semi-additive and non-additive. Non-additive stores some basic unit of measurement of all of a business process, such as ticket order number. After the fact table, you can have dimension tables. Okay, what is a dimension table? Dimension table is a companion table to the fact table and contains descriptive attributes to be used as a query constraining. What does that mean? Dimensions contain hierarchies for which to build with the facts. Okay, so the facts are like the building blocks, and then the dimension table you can pull off of that to build and use the information in different ways. Organize hierarchies of categories, levels, and members. You can see here pertaining to the flight information again. Well, now you can kind of organize it, say with the airports operating in the United States, and you can break it down, have the different hierarchies, West Coast, East Coast, and the states and cities, and so on. So you can organize the different facts in different ways to build them as the dimensions as needed. OLAP, Online Analytical Processing, allows for users to look at information from different angles and views while having the data brought in from different possible locations. Can be divided into as big or small of a picture as desired. One way you can do this, it's called an OLAP cube. Presents a 3D view of information on an X, Y, and Z axis. 4 types of analytical operations in OLAP are roll up, drill down, slice and dice, and pivot or rotate. Okay, disadvantages of an OLAP cube, and I'll show you on the next slide. Requires organizing data into a star or snowflake. Dimensions are limited. Transactional data cannot be accessed, and any modifications of the cube require a full update. Okay, so there are pros and cons to each one. The next one is a star. Okay, a star is a dimensional model implemented in a relational database management system. It can have one fact table with a number of attached dimensions to resemble a star. So in this example, in the picture, figure 1-1, you can see the sales facts in the middle with the different dimensions surrounding it and attached to it. The market dimensions, date dimension, product dimension, etc. Okay, and then that OLAP cube is off to the right. Most people are used to viewing an Excel spreadsheet in an XY, the data in an XY axis. Well, this can allow you to do 3D. For this one, you have product, market, and dates, and then you can slice it and move it and rotate it to get the information that you want. Now, building off of the star, you have the snowflake. Okay, it's an extension of the star, but adds more dimensions. It's more complicated, and it's unique, just like a snowflake is unique to the business need. Redundant attributes are removed from the flat denormalized dimensions table and placed in a separate normalized dimension table or tables. They're supposed to save data, but usually is minimal. The book gives an example. If you replace a 20-byte department description in the 300,000 row product dimension table with a 2-byte code, trying to save memory, you're saving a whopping 5.4 megabytes. Meanwhile, you may have a 10 gig fact table. So again, you might try and save data, but in the long run, it might not be worth it because some of the disadvantages are they're more complex to build, which may result in more errors in the database. Also, they're usually slower to process. An example of snowflake diagram is shown on the next slide. So here, again, you have the basis with the fact tables, and then you have certain dimensions off of that, and then more off of that, again, resembling a snowflake. What have we come up with? Well, in conclusion, after analyzing all of this data and the company needs, we recommend the star. Okay, the star was selected for its simplicity, redundancy, faster processing, and they're easier to update with the changing business demands. And below is a basic template for the design that the team will use. So for this whole process, starting out with the 4-step process onward, we're going to have individuals from all the different departments, department heads, IT, the BI team come together, and we're going to identify the facts and dimensions based and aligned with the company vision to make sure we have a good building block or cornerstone as we advance forward in this project. So with this, at the bottom here, you can see the facts are listed in the red column. You can have passenger key, ticket number, flight information, arrival, departure, airport, and then different dimension recommendations off to the left and right. Date, passenger profile, booking, time, airplane, services, etc. So this will be the framework as we continue and move forward. That is the conclusion of this presentation. Thank you.